All right, Calc. This is the second half of the notes for 6-6. This is the last section of the chapter. So tomorrow, tomorrow, we'll start chapter review, okay? But this is the Simpsons rule. Yesterday we did the trapezoid rule, okay? Kind of a tedious, icky way of finding area under a curve using trapezoids rather than using rectangles. But this is the method that you use when you can't take the regular antiderivative or when you can't take the antiderivative by substituting, like the u and du method. Okay, so neither of those will work. It's such an ugly equation that nothing else works. So we do what's called the trapezoid rule, and this is a more accurate area rather than doing the left and right endpoints for like triangles and stuff. So rather than having me set up and do triangles here or whatever, this will give me a more accurate answer. Okay, so that was the trapezoid rule. Then there's another one called the Simpsons rule, and I'm not really even I don't really even know what shape they're based off of or how they come up with this idea. But some guy with the last name of Simpson seems to think that this is better than the trapezoid rule. So this is what he came up with. He said that when you're approximating an interval, what you do is this right here, b minus a over 3n. That's what you're multiplying out in front, kind of like the trapezoid rule. You did b minus a over 2n, this guy right here. Okay, so b minus a over 3n this time. And then what you're doing is you're putting the numbers, or like your values that you're adding together. You'll put those inside, and the coefficients that you use out in front, you remember for the trapezoid rule, the trapezoid rule, the coefficients went 1, 2, 2, 2, 2 all the way through, and then our last coefficient was 1. So I would multiply and then add and multiply and add. Those were what I multiplied by each time when I was doing the trapezoid rule. For the Simpsons rule, okay, your coefficients go 1 for the first one. So you're going to take 1 times whatever you get when you plug that number in, plus 4 plus 2 plus 4 plus 2, and you keep alternating the 4 and 2 thing until you get to the last term, which is 1 again. Okay, now the Simpsons rule, there is one stipulation for the Simpsons rule. Because you're alternating the 4, 2, 4, 2, 4, 2 thing, the Simpsons rule can only be used when you're doing an even number of like separations of your thing. So like here we did like an even number of trapezoids. So I could not separate this into 5 chunks if I'm doing the Simpsons rule. I could if I was doing the trapezoid rule, can't if I'm doing the Simpsons rule. So that's the stipulation there, that n has to be an even number. Okay, so let's see how this breaks down. We are evaluating this thing from 0 to 1, first doing 4 sections and second doing 8 sections. I can't even call them trapezoids or rectangles because they're not really either of those. So 4 sections, 8 sections, all right? So here's what I'm going to do. I'm going to start with the 4 section one, okay? And I'm going to just do a number line, okay? And pretend that like this is where like my function is somewhere up here. It's some curve, right? And we're going from 0 to 1. And I'm just going to section him off into 4 pieces. So like this would be 0.5. This would be 0.25. This would be 0.75. Okay, that's what he will look like. All right. So there is that. Now, again, we will, when we're doing this, even though we have 4 chunks, 1, 2, 3, 4, we have 5 numbers that we will end up plugging in. So whatever the n is, you will have 1 more than that when you're doing like these guys here, when you're plugging those in. Okay, so we will do 0 first, then 0.25, then 0.5, then 0.75, then 1. Okay, all right, so this guy right here. The rule is, I'll write it up here, b minus a over 3n is the rule for Simpsons. That's what you're multiplying out in front the first time. So b is 1, a is 0, 3n would be 3 times 4. So this guy is going to be 1/12, okay? And then I'm going to start to do my chunks here in the middle, okay? Chunk, chunk, chunk. All right, the first number I'm going to multiply by 1, so I'm going to do that. That's my first number. And then I have a second one, and a third one, and a fourth one, and a fifth one. We have 5 numbers to do together, okay, because of these 5, right? So my next chunk, the rule goes 1. I'll write this down. 1, 4, 2, 4, 2, dot, 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 dot. But then we have to end with 4 and 1. And if you have an even number of numbers, you will always end with 4 and then 1, okay? All right, so I've got 1. Next one is 4, what I'm multiplying by. Then I'm multiplying by 2. Then I'm multiplying by 4. Then I'm multiplying by 1 again, okay? So that's how I do that. 1/12 goes out in front. And then to figure out what the numbers are that go inside of here, I plug these guys into my equation. So this guy, all right? So I'm just doing 0 into here. 0 plus 1 is 1, and the square root of 1 is 1. Okay, so that comes out nice. If I'm plugging 0.25 in, that will just be the square root of 1.25. If I'm plugging 0.5 in, that would be the square root of 1.5. Okay, if I plug 0.75 in, that's the square root of 1.75. And if I plug 1 in, that would be the square root of 2. Okay, so I'm just going to multiply all those together, or multiply each one of these chunks together, add them, and then I would divide by 12 or multiply by 1/12. And that's what I would get for the approximation for the area that is underneath of here from 0 to 1. Now, I think that's the same function as what we did over here, right? Yeah, from 0 to 1 of x plus 1. And our approximation that we got before was 1.1563. Hold on just a second. Kason Allen, turn that down. No. Help him. Oh my gosh. My son, thinks he knows how to run the TV, and then he gets his finger on the volume button, but it only goes up ever, of course, because, why turn it down? Anyway, all right. Okay, so 1.1563. So whatever you get for this should end up being close to what we got yesterday, okay? So maybe it's like 1.1578. I have no idea what it is, right? Okay. It's going to be close to that, all right? The ones that you're doing on your homework assignment, it says round of 4 decimal places. And the reason why you're doing 4 decimal places is because sometimes these get so close to being exact to each other that you have to go 4 decimal places out before there's a difference, right, between the numbers, okay? So we're going to go 4 decimal places. Now this one is asking for n being 8, okay? So here's the deal with n being 8. I still do this... let me see. I still do b minus a over 3n. So I have 1 minus 0 over 3 times 8. So this is actually 1 over 24 this time is what I'm multiplying by. Okay, but when I have 1/8, I have 9 numbers that I'm adding together. Okay, whatever. Let's see, how many do I have? 3, 4, 5, 6, 7. I'm going to move him over. 8 and 9, okay? And now my coefficients still are 1, 4, 2, 4, 2, 4. This is just a very tedious process, but this is the only, and that last one is 1. This is the only option that we have when you can't take the derivative. Now, I understand that you probably could find the antiderivative. Well, I don't know that you could, actually. Yeah, you could. You could, using substitution u into u, you could find the antiderivative of that and find the exact value. But this process is meant for really ugly equations that you can't find the antiderivative of. Okay, so, all right. Now, the really nice thing is that these guys right here, let me go up to my number line. All right, now we're sectioning them into 8 chunks instead of just 4. So I just need to add in here this guy, which is 0.125 and 0.375 and 0.625 and 0.875. Those are my extra numbers that I have in here, okay? Now, 1 will still be what I get when I plug 0 in, and that will go down here. So I'll have 1 here. This guy, the square root of 1.25, will be my third one, okay? This guy, the square root of 1.5 will go here. This guy, the square root of 1.75 will go here. And this guy, the square root of 2, will go in the last spot. Okay, now, it would be nice if we could use a shortcut, except here's the problem. This guy up top here was multiplied by 4. Down here, he's multiplied by 2. So we can't just like use these numbers and then add to that the 4 that we're missing down here, because our coefficients that we're multiplying by are different this time, okay? Some of them are different this time, all right? This one here in the middle, 1.25, if we plug him in, this is the square root of 1.125. This will be the square root of 1.375. This guy will be the square root of 1.625 and the square root of 1.875. Now again, that's these numbers that I was missing before plugged into this equation. And look at, I've made a mess of that in a hurry. Okay, that's doing 8 of them. We should get a number that's going to be close again to the 1.178 or 1578, except this one will be more accurate, because the more you do, the larger your n is, the more accurate your answer is, okay? Which is a pain in the butt, because yeah, we want to be accurate, but we don't want to have to go to all the work of doing that, right? So this is that process, okay? Now, yesterday, I think it was Kyle asked me, how do you find which one is better, the trapezoid rule or the Simpsons rule? And it goes back and forth. Some equations have an more accurate answer with the trapezoid rule. Some have a more accurate answer with the Simpsons rule. But there's no way of knowing really ahead of time which one is better until you calculate what the error is for each one, okay? And I'm just going to explain to you, like, I don't know, I don't have you calculate the error, but I'm just going to explain to you like how this works, okay? So the deal here is to calculate the error for the trapezoid rule, we do this thing, which isn't hard to figure out. B and A, we know that, and N, we know that. But then this is saying find the second derivative of your function. So like this guy, his second derivative is this. And it says use the maximum value of what you get when you plug in A or B. So here's the deal. If I plug in A is 0. 0, if I plug into the second derivative, they gave me the second derivative. If I plug in 0, this would be 1 to the negative 3 over 2 power, right? Like that's how that would work, okay? Whatever that is, 1 to any power is just going to be 1. So that's what I get when I plug in A, okay? If I were to plug in B, which is, well, let me go back. If I were to plug in B, B is 1, okay? And 1 squared is 1, so this would be 2 to the negative 3 over 2 power, okay? And 2 to the negative 3 over 2 power. Let's just talk about what that looks like. This is 1 over 2 to the positive 3 over 2 power, okay? Which is the square root of 2 to the third, okay? Which is really like the square root of 8, I guess I should say. 1 over the square root of 8. Well, 1 divided by the square root of 8 is going to be, I don't even know. It's going to be like 0.6 or something. I don't remember. 0.6 something, okay? So let's just say that that's what it is. I know it's something close to that. But anyway, they're asking for it. They want to use the maximum value. So if that's what A is and that's what B is, I'm going to go with the 1 because I want to use the maximum value. So the maximum value is 1 right here. All right. Now, you can figure out what the error would be by plugging this in and putting your 1 in, and that would calculate what your error would be using the trapezoid rule. The Simpsons rule is the maximum, but this is the fourth derivative. How pleasant. So you would have to find the fourth derivative of this guy, find the maximum value when you plug in A and B, so you'd use the higher one of the two, and then calculate this, multiply it by that, and that would tell you what your error is, okay? So very, very tedious process, but if this is your only alternative, this is all you've got. Like, this is what you have to go off of. Because if there's a function that you cannot take the antiderivative of using just the normal rules that we have for antiderivative, and you have to use the Simpsons and the trapezoid rule, and it's like you have to know which one's the better one, you would have to calculate the error going that way, okay? I'm not going to actually make you do that, all right? Let's talk about homework real quick. So you should hopefully have number 1 and number 2 done, and that's using the trapezoid rule. These two answers should be similar to each other, okay? 4 decimal places, so they might be a little bit off from each other. Actually, I think those ones come out as like whole numbers, like 52 or something. Anyway, but if it comes out as a decimal, round it to 4 decimal places, okay? So that's using the trapezoid rule. Then we're going to go into the Simpsons rule, number 3 and number 4. for n equals 4 and n equals 8. So see if you can figure out those guys. And then it just so happens that this function is not the ugliest function I've ever seen, right? It's not like a terrible function. We could have actually done the legit antiderivative of this thing to find the exact one. And that's what they're wanting us to do in number 5. So we can, using antiderivative, find the exact value by calculating it, and we're going to get the exact answer and then compare to see which one was closer, okay? So let me get that set up for you here, and we'll do like maybe part of number 5 together just to refresh our brains. So we're going from 0 to 8 of, I'm just rewriting this, 1/4 x squared plus 1. 1/4 x squared plus 1, and then we got dx. Okay, we do not have to use substitution for this one. And the reason why I know that is substitution usually is like composite functions. So if like this was this chunk squared, I would have to use substitution, right? It's like when you have a chain rule type of thing, okay? But this one is just like 2 pieces here that I can find the antiderivative of, okay? So if we're looking at just this part right here, x squared would be 1/3 x to the 3rd power, except I have to remember that there's a 1/4 there, right? Plus the antiderivative of 1 is 1x, okay? So really the antiderivative is 1/12 x to the 3rd plus 1x. And now I'm going to plug in my 0 and my 8, okay? So if I plug in 8, I don't have a calculator with me, so you guys are going to get this started, and then I'm going to have you fend for yourself. If I plug in 8, that's what I get there. Now, if I plug in 0, some of you guys probably already know this, what's going to happen. Plugging 0 in plus 1 times 0, that is gone. The 0 makes it go away. So all you would have to calculate is this guy, and that would give you what the exact area is, okay? So you can kind of guesstimate and see your 3 and 4 should be somewhere close to that, maybe not exactly that, and 1 and 2 should be close to that, but probably not exactly that, okay? So as soon as you find out what the exact one is, you can figure out which one was better, Simpson's or trapezoid, okay? Same thing on this backside one here. You're doing trapezoid rule for these two, Simpson's rule for these two, and they have different ends for each one. Except, hold up, we said n has to be an even number. So I'm going to change the instructions. This, let's change to 4, and this, let's change to 8. No, I could do 6. I could do 6. Let's do 4 and 6 instead of 3 and 6, because n has to be an even number for Simpson's rule. So 4 and 6, do that, okay? And then find the exact value area. So you could actually find the antiderivative of x to the 3rd power. Remember, that is x, or excuse me, the cubic root of x, which is x to the 1/3 power. So figure out what his antiderivative is and plug him in, okay? To find the exact one, all right? Work with each other, help each other out if you need to, but that is that, okay? There you go.